Here's a useful definition of a function. A function is an expression, rule or law that defines the relationship between two variables, one the independent variable and the other is the dependent variable. Here's a useful diagram that illustrates that relationship. The input values are what we call the domain, all those values of x. Now those values of x can be given to us or we can choose them. The output values make up the range. A function can have only one output value for each unique input value. So if I was to add in some arrows here, we could have something like this. That would be an example of a function. So each value of x has only one value of y. So the value of x1 has only one value of y. Now it doesn't matter if we have different values of x giving us the same value of y, that doesn't matter at all. So here we have an example of a function. Consider the second sets of numbers. If we had one arrow from the domain giving us two values in the range, then we do not have this statement being adhered to. So each unique input value can have only one output value. Well, here we have a unique input value, but it's giving us two different values of y. So this is a function here. Well, this represents a function, and this does not represent a function. If we want to find out whether the diagram that we have represents a function, what we can do is employ the vertical line test, and that involves drawing a line parallel to the y-axis at any point on the diagram. If that line intersects the graph at more than one point, then we do not have a function. Consider the diagram that we have here. What we want to do is to draw a vertical line at any point on the diagram. A vertical line, of course, is parallel to the y-axis. If that line intersects the diagram at only one point, then what we have is a function. Now this is a straight line that we have in the original diagram, so yes, this is an example of a function. Here's a second diagram. What we have here is a semicircle, so we're going to do exactly the same thing. I'm going to draw a vertical line through it at any point. And we can see that the line touches the circle, the semicircle, at only one point. So this is also a diagram which represents a function. Consider the third and final diagram. I'm going to draw, if I draw my vertical line here, you can see quite clearly that the line intersects the diagram at two distinct points. That being the case, we do not have a function. Consider the function y equals 2x. Now if we were to make a sketch of that, we would have something that looks like this here. I hope you can see from the diagram there are no restrictions on the domain, which is to say we can have any value of x, positive or negative, small or large, fraction decimal or whole number. Similarly, there are no restrictions on the range. Now this is only a small part of the diagram. The line will continue to extend in this direction and in this direction here. So here we have no restrictions on the domain and the range. And what would we state then? So x is a member of the set of real numbers. And as for y is also a member of the set of real numbers. Here is a diagram of the function y equals 1 over x plus 3. Now, I hope you can see from the diagram that there's a slight problem here, which is to say at x equals minus 3. At x equals minus 3, the function is undefined. So we have a restriction on the domain, and in this case we would state that x is a member of the set of real numbers, but x does not equal minus 3. From the diagram, I think it's clear that there are no restrictions on the range of the function. So here is a quadratic function, y equals 2x squared plus 3x plus 5. There are no restrictions on the domain, which is to say we can take any value of x, positive or negative. We can also have the value 0. The function is defined at x equals 0. That gives us the y-intercept, y equals 5. So, no restrictions on the domain. But what about the range? Well, consider the values of y. I hope you can see from the diagram. What we have here is a curve with a minimum turning point. So the smallest value of y that we can have is 3.9. We can't have anything lower than that. So the restriction on the range then would be y is a member of the set of real numbers. Y is greater than or equal to 3.9. One final example. Y equals 1 over x squared plus x minus 6. You may remember dealing with such functions in higher. Now, the denominator of this function can be factorised. That would give us x and x, 3 and 2, and plus and minus. What we want to do is to find out where the bottom line equals 0. We cannot have 0 on the bottom line of a function, otherwise the function is undefined. So what we can state then is that x can be a member of the set of real numbers. X can take any values, but it cannot take the values minus 3 and 2. So those are the restrictions on the domain.